Welcome to this video on feature flags and safe releases using AWS AppConfig. We will explore how to decouple deployment from release, empowering your product management and engineering teams for continuous delivery. This program is brought to you by the Series of Thoughts team as part of the AWS for Product Teams series.
We will cover four main areas. First, the PM angle, focusing on feature flags as a product strategy tool for launches, A/B experiments, gradual rollouts, and kill switches. Next, the dev angle, which involves setting up AWS AppConfig, integrating flag evaluation, and configuring rollouts with automatic rollback. We'll also cover flag hygiene, keeping your flag inventory clean. Finally, the key takeaway. Deploying and releasing are fundamentally different activities, and confusing them slows down product teams. Deployment is a technical operation of moving code to production, happening continuously and should be boring. Release is a product decision to make a feature visible, controlled, and reversible, independent of when the code shipped. Conflating these often makes product teams feel slow, even when engineers are shipping constantly. Feature flags change everything by decoupling deployment and release. You can ship anytime without fear, target releases with precision to specific cohorts, reverse instantly by flipping a flag, and experiment continuously with real production traffic. From a product management angle, feature flags move beyond a safety net to become a deliberate product strategy. They are a mechanism for controlling the user experience independently of the engineering release cycle. This shifts the focus from when can we ship this to what do we want users to experience and for whom. PMs use feature flags strategically in four ways: dark launches to test back-end changes silently, A/B experiments to measure different experiences, gradual rollouts to catch issues in small cohorts, and kill switches to instantly reverse bad experiences without deploying new code. A dark launch runs new code in production alongside the old one, but users only see the old path's results. It's great for major back-end changes, API integrations, new algorithms, and database migrations. For PMs, it provides real production signal before users are affected, removing the biggest risk of infrastructure changes. Ring-based deployment is a gradual rollout strategy to contain the blast radius. You release to small rings first, observe, and then expand. Ring 0 is internal. Ring 1 is beta users. Ring 2 is a small percentage of traffic. Ring 3 is the majority, and Ring 4 is the full public release. AWS AppConfig is a managed service within AWS Systems Manager for feature flag and dynamic configuration management. It stores, versions, and deploys configuration data without redeployment. It sits between your configuration source and your application. Being AWS native, it integrates deeply with services like CloudWatch, IAM, and Lambda. AppConfig organizes data using a three-layer model: application, environment, and configuration profile. This hierarchy simplifies having different flag states in development, staging, and production environments. A flag evaluation traces through this hierarchy to fetch the correct configuration profile for the application and environment. Setting up AppConfig involves four steps. First, define environments, such as dev, staging, and prod. Second, create a flag profile by defining a JSON schema with flag names and defaults. Third, create an AppConfig application named after your service. Finally, deploy the configuration using a deployment strategy to roll out changes. Feature flags are defined using a structured JSON schema in AppConfig. A minimal definition includes the flag name and an enabled state in the "values" section. You can also define flags with variants and attributes for targeting rules and A/B testing scenarios. The recommended method for integrating flag evaluation is the AWS AppConfig Lambda extension, which runs as a sidecar process. For non-Lambda workloads, use the AWS SDK. In both patterns, clients cache configuration and poll for updates, ensuring near-zero latency. On deployment, AppConfig issues a new token, prompting clients to reload their configuration on the next poll. A practical pattern is the "wrapper pattern," centralizing flag evaluation into a clean interface like "is enabled." This approach is default safe, testable by mocking "is enabled" in unit tests, searchable for cleanup, and observable for debugging gradual rollouts. Deployment strategies control the rollout pace and provide safety guardrails for configuration changes. AppConfig manages how flags are deployed over time, with every update following a defined strategy for a controlled, safe release. AppConfig ships with 3 pre-configured deployment strategies. All at once for urgent low-risk changes, linear 20% every 6 minutes, a good default for production releases, and exponential growth, which starts slowly and accelerates, best for high-risk changes where early feedback is crucial. You can also define custom strategies for specific needs. The most powerful safety feature is automatic rollback with CloudWatch alarms. If metrics like error rate spike during deployment, AppConfig automatically reverts to the previous configuration, closing the loop between release control and observability without manual intervention. To configure rollback, first define a CloudWatch alarm on a user-facing health metric, like the 500xx error rate. Then, attach the alarm's RN to the AppConfig deployment command. AppConfig continuously monitors the alarm and triggers an automatic rollback if it enters an alarm state, meaning your on-call engineer doesn't need to manually monitor. For serverless applications, AWS Lambda is the primary flag evaluation surface. The AppConfig Lambda extension works as a sidecar, handling communication. It caches the configuration in memory for low latency, under 2 milliseconds, local HTTP calls, and features background refresh to automatically propagate new flag values without cold start penalties. AppConfig lives within AWS Systems Manager. It is optimized for dynamic, deployment-managed configurations like feature flags. In contrast, AWS Systems Manager Parameter Store is better suited for static secrets and configuration values that change infrequently and don't require deployment strategies. The stale flag problem is real. Many engineering teams accumulate hundreds of flags, losing track of which are active and which are dead. This results in technical debt, dead code, and increased complexity. Maintaining flag hygiene is essential for successful feature flagging. The flag lifecycle has 5 steps: creation with defined ownership and removal date, active rollout with traffic control and monitoring, fully released meaning it is 100% enabled, scheduled for removal with a cleanup ticket, and finally, removed, deleting the dead code and archiving the AppConfig profile. Good flag hygiene requires discipline. Every flag must have an owner and a predefined expiry date. Enforce a strict 2-week rule for removal after full release. Maintain a flag registry in your code repository. Utilize static analysis and continuous integration checks to identify stale flags. Not all flags are the same. They have different lifespans and risks. Short-lived flags are temporary controls for immediate launches. Medium-lived flags support A/B testing and rollouts. Long-lived flags are permanent, like kill switches or geographic controls. Feature flags foster collaboration between product managers and engineers. The workflow involves engineering shipping code with the flag off, the PM defining release criteria, starting the gradual rollout, and finally, the team deciding whether to proceed or roll back based on metrics. To measure a rollout, monitor both technical signals like error rates and latency via CloudWatch, and product signals like conversion rate and user engagement using your analytics stack. Always define your metrics before starting the rollout to avoid flying blind. In a real-world scenario, like a new checkout redesign, the process involves shipping the code with the flag off, followed by a dark launch for back-end validation. Then, a beta rollout to internal teams and a small traffic percentage. Finally, ramp up to 100% gradually, monitoring conversion and errors before retiring the flag. AppConfig pricing is based on configuration receives, which are API calls to fetch configuration. The Lambda extension significantly reduces costs by caching. For most SaaS teams, AppConfig is highly cost-effective, with pricing starting free for the first 10,000 receives per month. Avoid common mistakes by never calling AppConfig on every request. Always use caching or the Lambda extension. Always define a safe default for flags and handle exceptions gracefully to prevent application crashes. Ensure every flag has an owner and don't use feature flags for permanent configuration that belongs in Parameter Store. In summary, decouple deployment from release. Recognize that flags are a powerful product tool. Automate your safety net with CloudWatch rollbacks and prioritize religious cleanup of stale flags to manage technical debt effectively. Module 4 will focus on data, analytics, and product intelligence. We will explore how product teams use AWS for evidence-based decisions, covering topics like choosing the right data store and building scalable analytics capabilities.